So the next set of directions asks us to graph linear equations using 3 points. Then we're also supposed to state whether it's a function or not. And we're going to use the vertical line test to determine whether it's a function. So let's take a look at that first one, letter A. We've got a graph set up. Y equals 2x plus 1. So whenever I'm graphing using 3 points, I'm going to try to pick my values as I'm doing it. I'm going to make, instead of just a t-table, I'm going to make this kind of chart. It's x, and then I'm going to write the function in here. Function is 2x plus 1. This is like the rule for y. So you got to do this work here. You got to do 2 times x plus 1, and that gives you the y value. And then I'm going to come up with my outputs, which are my y values. So these are like my inputs, and I'll pick a negative number, like -1, and 0 is always a great number because it cancels out the x term, and then +1. Those are nice, easy numbers to deal with. And so I just go ahead and plug in the -1 for x, and then do the work. 2 times by -1 plus 1. So we can do this work in our head. 2 times -1 makes -2. -2 plus 1 makes -1. And so I can plot this point, -1, -1. So I'm going to go from the origin over 1 space to the left, and then down 1 space. And so there is my first point. Let's try the next. And then we plug in 0 for x. So I've got 2 times by 0 plus 1. You can see how nice plugging in 0 is. It cancels out the x term. So I have 2 times 0 is 0, plus 1 makes 1. So in the x direction, I go 0 spaces. Y direction, 1 space. So over 0, up 1. Let me put a dot. Last point, 1 in for x. So it's 2 times by 1 plus 1. So we do that work. 2 times 1 makes 2, plus 1 makes, you got it, 3. So we go over 1 space in the x, and then up 3 in the y. Over 1, up 3 spaces, and there it is. So those are our 3 points. We can go ahead and draw the line, and just really carefully try to get it right between those points. Put some arrows at the end, signifying that the line goes on forever in those directions. Well, let's try another one. -x plus 3. So go ahead and set up my little chart here. Probably use the same numbers again. Typically use those numbers, but sometimes we'll run into a situation a little bit where I probably wouldn't pick those numbers. So here's the rule, -x plus 3. That's the rule for y. So here are the inputs, x values. Put those inputs into this rule here, and it spits out outputs, y values. So I'll go ahead and pick these same points, -1, 0, and 1. Now for this first one, though, we're going to put -1 in for x. Remember, as I said before in that last part, the minus x means the opposite of x. So it's like the opposite of -1 plus 3. Well, the opposite of a negative makes a positive. So really it's just 1 plus 3 to make 4. So I'll start in the x-axis, and I'll go over 1 space to the left, and then up 4 spaces. Put a dot right there. Then do the same thing with the next one. 0 in for x. Well, there's no -0, it's just 0. 0 plus 3 makes 3. So that's a nice one to go over 0, just up 3 spaces. Put a dot. Move on to the next one. 1 in for x. Remember, this is the opposite of x, opposite of 1 plus 3. And so that makes just 2. So over 1 in the x, up 2 in the y, we have ourselves another point. So from there, all you have to do is draw the line. Notice this line's going the opposite direction. It's going downhill from left to right. Whenever it goes downhill from left to right, it means we have a negative slope. Here, we have a positive slope because it's going uphill from left to right. As my x values get bigger, my y values get bigger. That's considered positive. This is negative because as my x values get bigger, my y values are getting smaller. We'll talk more about that in the section that deals with slope. Now let's take a look at the next one here. Here we have a fraction. This is where I'm going to pick my numbers carefully for x. So instead of picking 1, I'm going to pick numbers that 2 goes into. So I'm going to pick even numbers. So again, you can pick -1, 0, 1. You get good answers. It's just that I'm going to try picking numbers that don't give me fractions at the end. So again, here's the rule. 1/2 times x minus 1. And we go ahead and do that work, and we get our outputs, our y values. Fix this -1 a little bit here, make it look a little bit nicer. So minus 1. So 1/2 x minus 1 is our rule. So when I do this, I'm going to pick these even numbers. I'm going to start at -2 this time, still pick 0, but I'll try +2 as well. So here it is. 1/2 times by -2, and then take away 2. So 1/2 of -2 makes -1. -1 take away 1 makes -2. And then when we plug in 0 for x, that's nice because it cancels out the 1/2. So I'm just left with this -1 is the number there. And then for 2, plug that in for x. 1/2 times 2 just makes 1. 1 minus 1, hey, that cancels out. That makes 0. So again, I was careful as I picked my values. Let me go ahead and plot those points. So x direction is -2, y direction -2. So over 2 to the left, down 2 spaces. And then we go ahead and put that dot. Do the same thing with the next one. This time x is 0, so don't go over any spaces, just down 1 space. And here we have x is 2, y is 0. So over 2, up 0. So what kind of line is this? Is it a positive slope? Is it a negative slope? Now this one is a positive slope. As my x values get bigger, y value is getting bigger. So that's considered a positive slope. Now let's take a look at the last one here. X equals 3. Oh, what happened to the y? Well, if you don't see y, that means 0 is the number out in front of y. 0 times y makes 0. That's why you don't see the y term. And then plus x equals 3. So this one's nice. You could just plug in any number for y, and it makes 0. And then our x value is always going to be 3. So we'll see that. We'll just pick any old numbers. So our rule this time is different because it's going to, we don't have the y value by itself like we did on the other ones. So I'm just going to write in what I have. So I'm going to write in y plus x equals 3, except I need to put a 0 out in front of the y. 0 times y plus x equals 3. And you'll see when I go ahead and substitute numbers in for y this time instead of x. I'm putting in for y because I can put any number in for y. It doesn't matter. It could be 1, it could be 2, it could be 3. And any time I put in a number, it doesn't matter what it is. It could have been 100. See, 0 times by y, which in this case was 1, plus x. Well, this makes 0. This cancels out, so I'm just left with x equals 3. So x equals 3. Put in another number there, 2, in for x, plus x should equal 3, and it does because 0 times 2 makes 0. X equals 3 again. Do another one, doesn't matter what it is. It could have been -5, but I chose 3 for the next one. 0 times by 3 plus x, well, it equals 3. So these 0 times 3 cancel out. So every time, it doesn't matter what y is, x is always going to be 3. So when we go ahead and plug or plot these points, we go over 3 spaces every time because x is always 3. So my first point's here. Second point, over 3 and then up 2. Third point, over 3, up 3. And we got ourselves a vertical line. So there it is. So those are the 4 different types of problems, but they also asked us whether they're functions or not. And so if we look at them, the only one that's not a function is this one. The only type of line that's not a function is a vertical line. Every other line passes the vertical line test. So no matter what, we could draw any type of vertical line through any of these lines, and they would pass. So the only line that's not a function is a vertical line. So let's write that down. The only line that is not a function is a vertical line. So all other lines have one number for each domain. Every domain has one and only one range value. So the only line that is not a function is going to end up being a vertical line, because the domain 3 has multiple ranges that make it up, like the 3 numbers that we came up with here. But every other line is going to pass that vertical line test. So those are the types of problems that you end up having. So you just graph the lines and state whether it's a function or not. If it's not a vertical line, you say it's a function. And the reasoning would be that each domain, so if it is a function, we'll say if a function, and any type of line is a function unless it's a vertical line. If a function, the reasoning is all domains have one range. So those are the types of problems you'll see on tonight's homework.